explained that we are going to talk about mission planning, the use of SDK,
Yeah.
and
Yeah.
they're very eager to learn about this because they want to start planning their missions and start using the flight plan assembler ASAP. So
Perfect. Yeah.
it's the floor is yours, I would say.
Great. Can I share my screen, or are you
Yeah.
sharing the slides?
No, I think it's better that you share your screen because then you can just click through it yourself, I would say. And
Yeah.
you're on a big screen, so everyone can see you loud and clear and hear you loud and clear.
Perfect. Okay, let me share my screen here. So let's see if this works.
Yes, we can see your screen.
Can you see? Okay. Okay, I don't see my own screen on the stream, but
No, yeah, we haven't put it on the stream. I don't know if that's possible even to put it on the stream.
well, it is fine for me if you guys can see my screen.
Can we turn around the webcam?
หมุนแคมเข้ามาหาเราเอง
Is that possible? So people can see us through the.
Oh, no problem. No, man. No. You know Mac guy, what?
Yeah.
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 He
เดี๋ยว
is.
ว่า
Who is
He can do anything if you like it, except the real work.
the real work?
Wow.
Is that the right video?
Okay, I'll be ending. Okay. So the picture you see has been taken with FB1.
Okay. Why is
Yeah,
Why it is?
this is in Tibet,
Tibet.
one of the highlands.
You know,
Yeah.
the world is so so different. Right? The
Yeah.
world. I mean, when we have the satellite, we can see some of the strange part of the world.
Oh, yeah.
Water, ice, snow,
Yeah.
and you see.
I mean, we have been amazed a lot of times when we first saw the cracks in the ice of Antarctica and then the
This
desert.
is
was
supposed to
amazing.
be the snows.
Yeah, that's snow. Yeah, on the mountains.
The
Yeah, you can see the mountain.
Yeah, it's the water, right? If you said it like lake,
คืออะไรวะ
Yeah.
could be the lake.
That was the target. Lake.
Yeah.
Yes.
Yeah.
ตรงเนี้ย
Oh, yeah.
Can apologize.
I have to so
Okay, so there. I don't know if you're able to see us now. You are, I think, right? In the YouTube channel.
Let me refresh the page just to be sure. No, I still see the main screens, the major column, but otherwise I'll just start. It's fine.
Okay. Yeah. All right.
ปิด
Then,
กล้องกล้อง
then let's start with the training. I would say.
ปิดนั้นเปล่า
Yeah.
เดี๋ยวมีสองกล้อง
Okay. So welcome everyone. Indeed, as Hong Yang explained, I'm going to talk about the flight planning and the image acquisitions, and also show you or tell you a little bit about the day-to-day operation plan, and give some examples of how we did it during the commissioning. So I think most of you are aware of who I am or have seen me in the Netherlands or in Thailand before. So I'm Hugo Brouwer, one of the system engineer on FB1, and I'll guide you through this presentation. So, let's see, this works, yeah. So I'll first talk about day-to-day operation planning, then I'll go through how to set up a use case where we're trying to target or multiple targets, a little bit about the flight plan assembler, and then finally I also a bit about a mission use case, explain the user manual, but I think we need to quickly highlight the steps you would need to take in order to time sync or sync the time with the GPS. Okay, so day-to-day operations, some more general stuff first. So what is important, and I think that we'd already explained that or even showed you during the last few boss blocks that were. So make sure you always plan for the daily operation in advance. And the main goal is to minimize pressure on the operators themselves. So make sure you have a plan with which the operators can work with that in case you do need to switch or something happens, it's easier for the operators to simply focus on one or two things at the same time. It's also advised to plan for a few days ahead, and I'll also mention that for imaging. So for imaging, it's actually best if you plan 1 day in advance, because then you have the most accurate data and target outputs. But it is already good to plan for the coming days ahead, so you know what targets will come in view, and if there are any specific operations that you need to carry out. And then finally, versatility is key, and I think that's something you have already been seeing. I think in the first pass block in Thailand with the feed, where beacons were received, and it was found that, for example, the ADCS need to be rebooted because one of the reaction wheels was actually spinning at a fixed rate instead of varying over time. And there you can see that there may be instances where one of the subsystems doesn't act as it should be, and then you need to either reset the subsystem or do some other operations. And that means that only leaves very little time during the pass for any of the other operations that you may have planned for. So always be prepared to do some troubleshooting. So how to plan? So time and their elevation, so that you know, okay, when do we have contact with the satellite and what tasks can we plan for in each of the passes. Make a high-level plan. So as I just explained, check which images you can take in the coming few days, when do you want to download them, including your metadata, and when are you going to plan for the housekeeping, so the weekly VOD and the GPS time sync. And then if you have a good high-level plan or an overview of all the tasks, you can assign priorities based on your own needs or a customer needs, and then you can fill in the operator's task per pass. And I'll show you an example of how we did this during commissioning. So this was quite early commissioning, where I made a plan for the entire team, where I listed the 4 passes we have in Delft in the morning, including their elevations. So we know the higher the elevation is, the longer we have contact with the satellite. And then for each pass, I listed the tasks that we should, that helps or help the operators to already queue all the commands before the pass, so that they only need to execute them during the pass itself. And it makes it really easy to see, okay, what is the plan for this particular day. So I would advise you to do something similar here. Can be in this way, can be in another form, but that really helps keeping the focus on what needs to be done in each of the passes. Another example, and I think this is a good example for you to think about when you're taking images. So during the commissioning, we kept an Excel sheet, and that basically provides a list of all the images that we planned for, that we took, and what the status of those images are. And yeah, basically I use this to tell the operators, okay, please plan for these images, and the operators could tell me in return, did we plan for them, and what ID number, for example, did we give it. So first of all, make sure you have a list that shows, okay, which targets are of interest, and what is their date and their timestamp and the roll angle that we need to apply in the flight plan. I already showed you an initial flight plan with images from New York, if I'm not mistaken. So there he has shown you need to tell the spacecraft, okay, what's the timestamp of when the image needs to be taken, and what roll angle do I need to set to the ADCS. yeah, by having such an overview here, everyone can keep track, or the operators can keep track of what needs to be imaged in the coming days. And the second aspect is planning. So we would indicate, okay, what format should we download after we've taken the image or the satellite took the image. I have sometimes assigned a priority which image needs to be downloaded first. And the operators could indicate, okay, do we accept this image or do we reject it? And a rejection can be done if it's not possible to take that image because another type of operation or plan takes priority. And we also have a list of image IDs here. So if you want to take an image, you assign a unique number, and then basically that number is assigned in its header, and then later you can download the image by using this number as well. And this is easy because it keeps track of which number or which image represents what. And then finally, or next is the overview of images. So a simple overview of showing what the status is of each of the file types. So did we download everything? Is everything on ground or is everything on board? And what to do with the data? Shall we erase it or? And the metadata overview, so we simply added this for everyone to have a quick look at it instead of having to go through Major.com and click on the exact image. But it's something we get track of during permission to show, like, okay, what are the results in terms of raw angle versus what we asked for, etc. So, yeah, to give it.
Hugo,
Go ahead. Yeah.
one
you
second.
turn on your microphone.
Yeah, now turn it on, yeah.
Oh, you yours. It's your computer. Is this computer?
Still hear me?
Can you turn on? Can you put doing?
พี่ครับไมโครโฟนของคงยังออนอยู่
Yeah, now mine is on, yes?
Yeah.
You want to say something or?
Okay.
ไม่ของคุณยังมิ้น
Yeah.
อ
No, I
ยู่
think
แล้วมันย้อนกลับเข้าไป
I think there was
Say something,
something.
Hugo.
No, it's like sometimes your sound drops a bit. I don't know what it is because I'm muted.
Turn off,
I don't know if there's
ใช่
any.
ครับต้องของคงยัง
Could you turn off yours?
Yeah, mine was off. It's not because of my microphone because it was
แล้ว
off
ไมโคร
when
โฟนตัวนี้คือ
it,
ตัวไหน
there's some
ของ
other.
ผมก็มีแล้วของผมปิดหมดแล้ว
นี่ของโกโก้แต่ของเขาปิดแล้วนี่ นี่ของ
It was off during the
ผม
school
ดัง
period.
นิ้วเรียงครับ
already mute already mute
Okay, just let me know if I need to explain something else again.
You already muted?
So currently I'm not muted, but I was muted the whole period. So
Okay.
it's something else that causes to drop every time. So I'm not sure if.
Hugo microphone.
Yeah, I don't know, Hugo. You're using your standard microphone, right? No.
Oh, I'm actually using my own headset, so it should be actually better.
Okay. Yeah, it's dropping it like once in a while, or it's too. I don't know what it is.
okay
But let's try
I
again.
can also use the I can also use the mic of my laptop
no
if you
problem
think that's better.
You can
That's
try.
okay.
I don't know.
that's okay
Let's see.
that's okay
I'll just mute now, but you continue.
Okay.
okay
Yeah. And otherwise, just let me know.
okay
Okay. So I'll continue. Yeah, an example of nominal operations is before pass to the image acquisition planning. So I'll explain using the system toolkit for that. Make sure those images are being tracked. So you use something similar as I showed before, where you list which images need to be taken, assemble the flight plan, and then during the pass, the operators can upload the flight plan, which contains enabling of beacons, perform the image acquisitions, transfer the images from the camera to the PDHU, and then we, in the meantime or later, download the images and metadata and perform daily, weekly housekeeping tasks. So that's in a nutshell, how we advise to plan for the operations. Now, I think the most important stuff is how to plan for an image and take the image. There there are a few things we basically need to know in order to carry out this task. So first of all, we need to know if there are any requirements or constraints for a target. So are there any limits that prevents us from imaging a certain target? And second, we need to know the latitude and longitude of the target. We need to know at what time we need to take the image and also at what roll angle. And then finally, how can we build a flight plan to actually take the image and tell the satellite, okay, take this image at this moment in time. So what are the requirements and constraints? So there are a few things you need to take into account. First of all, since the camera takes snapshots in the visible wavelength, we basically are looking for targets that are available during the sunlit part. So we need to have sufficient illumination. So that means no nighttime imaging. That will, even if a city is quite lit up due to a lot of lights on the ground, it will be too cold for the camera to actually take images. And it's almost certain that there's not enough light for the camera to actually see something. So the target can only be imaged when it's in the sunlit part of the orbit. Then the latitude. So I've put these numbers here. This is based on our experience during LEOPS commissioning. So there's a limit as to where you can take the images while in the sunlit part of the orbit. So I try to indicate it a bit here. When the satellite just comes out of eclipse above here, the satellite itself may already be hit by sunlight. But the ADCS first needs to acquire a sun and nadir vector in order to properly point itself, which usually means that in the first part of the sunlit part of the orbit, it's going to be very difficult to actually take an image since the ADCS will readjust based on its sensor data. So we typically advise to take images only between these latitudes. Then another important one is check the weather forecast. So make sure that the area is cloud-free. So we've taken quite a number of images, also from Thailand, but also from other parts of Asia or Europe or the States. And a lot of time we got images like these, where you could see that there are a lot of clouds, and you basically can't see anything. So here you can actually see a little bit of shoreline, a little bit of land, but for the rest it's cloudy. And we've even seen images that are fully covered by clouds. So in order to save link space or link data or link budget, it's good to check up front what's the weather forecast. And if it's really cloudy, then you could opt for not taking images. You should also make sure that if you have multiple targets after each other, then make sure there's sufficient time for the ADCS to repoint. And and especially if you think about images that are next to each other, then you would need to wait for another orbit in order to image it, because you can only, of course, take one image at a time with a 1 second difference between the next, and they should be not on the same latitude. So those are the aspects you need to take into account and which you can check up front. So computing the target properties. So in order to take the images, I said it before, you need to provide a command to the satellite for taking an image, and you need to know at what time, and also tell the ADCS to what angle it should roll. So important, we need the timestamp and the roll angle, which should go into the flight. Then in order to get these parameters, we need to compute those based on the target's latitude and longitude, and those are dependent on the satellite position in time, which is given by the TLE, so the two-line elements. So how does the flow look? So the flight planning flow, we get the latest TLE, we set our targets in SDK, and I'll show you that in a bit. You run the analysis for 24 hours or maybe a week, so you have a good idea of what will come in the coming week. When the analysis is run, you can derive the roll angle and what you need to image. And you're gonna build the spacecraft. You're gonna upload and activate it. So this is the bit I'm gonna explain you now. So it's the systems bit, and that allows you to set up the satellite scenario. You can insert targets, and that's all based on your TLE, so you get a picture of where your satellite is going to fly over in the coming days. So I'm gonna give the demo. I just wanna let you know that I've basically put everything in the slides here. So I'm gonna show it live now. But later, if you wanna look it up again, you can always refer to the slides because I've gone through all of the steps you need to take and made screenshots. Because we figured that's probably quite convenient if you wanna look it up there. So
Okay, yeah, that's okay. So they're also making a video here. So I think
okay.
then we have it on two sides. Great.
Yeah. So I'll first show the demo here, and then thereafter I will quickly go to the slides, and you can see that it indeed matches. Okay, so this is SDK in the beginning, the system toolkit. There's a free version or a free part to it, and there's a paid part to it. So we're going to use the free version, so you can basically use it to plan for images. There are some limitations, like for example, for the satellite to actually roll. That's not part of the free version, but I'm going to show you how we can still get a roll angle from the actual analysis. So we're going to create a scenario. We're going to give it a name, and we're going to give it the on-the-job training 2021. You can add a description if you want. And what I'm going to do is I'm going to set a date, which is the beginning of this week. So this was yesterday, but you can basically pick the day from now until whenever you can select the longer period, the shorter period. I'm just going to do this week to show you, in this example. So it's going to generate the scenario for me, so it needs to load. Okay. So here it is. So I'm not sure if any of you already used it or opened it, but basically what you get is two screens. So we have a 3D view and we have a 2D view, and it immediately pops up a window which basically shows, okay, please insert a object. So in this case, we're gonna insert a satellite, and we want to insert that from a TLE file because we have the TLE and we should go for the latest TLE. So always make sure that you download the latest TLE file for your satellite. So in this case, for FB1, from the internet or wherever it's easiest available. And we're gonna insert it. So we're gonna select the TLE file. So I have it stored on my desktop. And I have the latest TLE that corresponds to yesterday, which I have set as a starting date. And I'm going to insert it, and it immediately gives me FB1 as name, and it shows, okay, the time this TLE was created was yesterday at 4 o'clock UTC time, which is fine for now. So I'm going to leave it. I'm going to say insert, and you will see that it will add the satellite here. With the name, and here it is. So we're going to close it, and then you can actually see the satellite going over the Earth and you can basically, if you click on play here, you can see it in time what the expected position is. All right, let me quickly. Okay. So after we've inserted it, we're gonna add a sensor because we need to tell the spacecraft or the program that we have a camera on board, and we want to know, okay, what's the footprint of the Earth, and when is a certain part. So I'm gonna add another object, this button, and I'm gonna say add a sensor, and I want to define the default properties. And I'm going to select, please attach it to number 1. And then I'm going to click OK. And you see that it has added it over here. So it's now attached to the satellite. And now you can basically select, or you can basically choose from 2 types of sensors. So a simple conic one projects a circle on the surface, and a rectangular, that's what we actually want, that simply projects a rectangle on the Earth's surface. So as you can see, there are a couple other options which are grayed out, and that's part of the paid version, so we can't use those, but we also don't need those. That's lucky for us. So I'm gonna pick the rectangular one, and then you can define basically the half angles. So those angles tell you in the end how wide or how large your spot is, and basically your footprint on the Earth. So for the Gecko camera, the half angles are basically 4.55 and 2.49, and I can show you what it does. So this is still the circular conical one that was by default. I'm going to have to say apply now. It shows it has inserted a rectangular footprint. So this is the instantaneous view of the camera when it's simply looking native. So those half angles are basically from the bore side to one of the axes, so it's half the angle of the full field of view of the camera, and this translates to approximately 85 to 90 kilometers at altitude that number 1 is flying, and the horizontal one, which is basically the short length, amounts to roughly 46 to 49 kilometers on ground. So I'm gonna say okay. I'm gonna close this for a bit. So what we can do is we're gonna rename this to SWAT. SWAT is the instantaneous view of the Gecko image. So you can see in the 3D view, it now shows you how the sensor goes over the Earth and what. So that basically gives you a view of what comes into you, or a look at what comes into view. So that's the first thing. Now we need to remember that in this free version or free part, the satellite can't roll. So we need to take into account that although this is fixed here, the satellite is able to also look at targets left and right. So what we can actually do is add another sensor. So I'm gonna add another object, same as before. I'm gonna say insert, and I'm gonna attach it again to number 1, and you'll see a second sensor is created here. And then I'm gonna say again, we need a rectangular sensor type. And I'm basically gonna say that the so we have the vertical off angle is then basically our maximum roll angle. So that's 20 degrees. And then this one, so the horizontal remains the same. So it's 0.49. So we only change basically the dimension of, you should be able to see it, of the left and right So you can see it now added a bigger square area around our initial spot. And this basically represents, so from the center of the satellite to the edge, which is 20 degrees, shows you, okay, what is the maximum view that the satellite has to any target. And it can basically obtain that by rolling the satellite to that specific angle. So now I've inserted the second one. To give an example, you can give it a different color. So, for example, I can give it a very light white color. I'm going to say apply, so we can see a nice difference between our slot and the center. And I'm going to rename this. Name this field of regard. The field of regard is thus your full view that the satellite or camera can have, although it needs to roll for it. I'm going to say okay. I'm going to close this window, and you can nicely see now that over here we basically have the full picture. So we have our SWOT, so that's the instantaneous view, so that's what we can actually image, and we have the range in which this SWOT can move. So any target that falls within the white area is available for the satellite, but it needs to roll to a certain angle. Okay. So that's it. So we defined our satellite. We've defined the sensors, and the next point is to insert another object, and that's actually a target. One note I'd like to make, so there are two ways of planning for images. So one is what I'm going to show you is insert target. Certain targets can be based on latitude, longitude. It can be or it can be based on a certain address. But obviously there's also a possibility to simply look at where the satellite flies over. So in this case, if I manually see that the satellite here flies over Spain, I could simply say, okay, I'm gonna stop it here, and I'm gonna take an image exactly at this spot. And then I simply would have my scenario time, which is the timestamp that I would need to take the image here, and then with the raw angle of 0. So there's also the possibility of simply checking where is the satellite flying over, and simply take that time as the timestamp for the take image command. But what we're more interested here is to see what happens if we add a target. So I'm going to add another object, and I'm going to define target. And you can see here on the right there are a few options. So we can search by a certain address, we can go for a city database, we can insert a default or define properties. So right now I'm going to define the properties. And what I'm going to do is I'm going to have a look at here. I'm going to base my target on the latitude and longitude. So what I'm going to do is I'm going to look at the list we had for our targets initially. So this is basically our initial list. And I can say, okay, I'm interested in imaging our target in Thailand. So these are the latitudes and longitudes that I've used before in order to image the art of main headquarters. So I'm going to insert these. So I'm going to have the latitude here. Latitude, longitude, you can simply find or you have it through any other source. But if you have them, you can insert them here. Say apply, and based on the map, it automatically gives you the altitude of the target. There's a possibility to change this if you want, need it. So I've added this you can give it a nice color, so I'm going to give it red as a real nice color for a target. I'm going to click OK, and
โอเคครับ
I'm going to give this
พวกพิกัดพวกที่ตรงนี้ปรับปรุงนะครับนี่ต้องใส่ความสูงเราเทียบกับ target
my target name. So now if I
เลขที่สามเลขแรดลงเลขอันนี้เลขที่สามแรดลงเลข
ระดับความสูง
เอาที่จุด
ของเป้าหมาย
we now see it has made a target based on our latitude and longitude.
เอาความสูงจาก
เดี๋ยวก็เล่นได้เลยดูเลขตัวนี้
ตัว
See
มีแผนที่เป็น
อ๋อมันมี
find our targets.
นี่เลย
เอเวชั่น
It's basically where it should be, if I'm not mistaken, because I can see here the airstrip. So it needs to load a bit. So it has targeted the Art of Airfield. So I think
ใช่
this
พี่
is
ถ้า
quite
เขา
spot
ปัก
on.
หมุดแล้วก็กลางดูเลย
So we defined our target here, and what I'm going to do. So this is one opportunity. So we're going to use the latitude longitude. But we can also add another target, and we're going to search from a city database. So that makes it a lot easier instead of manually looking for latitude longitudes. So I give the example of New York. We're gonna look for there are a bunch of New Yorks in the world apparently, and we're gonna say we're looking for the real main city, New York. Give it a color red, and I'm gonna say insert. So I just add it here, and I'm gonna close this one, and now you can see it as added. So I've added 2 targets. In principle, you can add as many targets as you want. It's just the more you add, the longer it takes for SDK to actually compute the output you need. Okay, so now we're all set. We're almost all set. And we basically defined everything we needed to, and we're gonna check for the axis. So there's a button here which is called axis, which we're gonna click on. And basically what this gives you is the possibility to compute the axis between a sensor and a certain target, or vice versa. So what we're interested in is we wanna basically see, okay, for our field of regard. So remember, we want to know when any of the targets fall within the full available area of the satellite camera field, plus our roll angle left and right. So I'm interested in to know in what any of these targets, or whether the field of regard has any access to these targets. I'm going to list them both, and I'm going to say compute. Here you can compute time period, so you can change dates, for example, but I would also suggest to only change the scenario time and leave this just a default. So I'm going to say compute. You can now see it has sort of these green V's attached to it, so it has done the analysis. It went really fast. But now the next step is to actually find the timestamp of when it sees either targets. Could also be that it doesn't fly over any of the targets. But that's something we'll find out. So I'm going to go to report in Graph Manager. And basically what you see here is, here you can see the axis computed. So we have the field of regard to our target in Thailand. And here we have our field of regard to our target in New York. So it computed those 2, which we actually wanted to. So that's good. Now the thing is, the default styles or the default analysis reports that are installed are not giving you the roll angle yet. So we need